Good morning students. Welcome back to this Sheba online class. Today also we have to continue this P block elements. Already we completed the 3 classes. We already fed up I think. Don't fed up. I am going to wind up that P block lessons and have to continue this lesson. For what? You have to watching that videos till to the end. Okay? And the next concept after that carbon monoxide, this is the carbon dioxide. In this carbon dioxide, you know very well about that chemical formula, that is CO2, and this is how to product of the manufacturing of the CO2. I am going to explain through this chemical formula. 2CO, that is 2 molecules of carbon monoxide along with the oxygen, we can get the 2 molecules of carbon dioxide. This is the versatile equations to have the manufacturing of that carbon dioxide. In this enthalpy, the energy level is 394 kg per mole, that is kg mole minus 1. Okay. Then go for that another manufacturing of CO2, carbon dioxide. We have to insist of the decompositions of what is that? Calcium carbonate. In this calcium carbonate implement to the decomposition reactions, have to get that calcium oxide along with obviously carbon dioxides. And we go for that calcium carbonate along with the presence of hydrochloric acids. Again we have to get that CO2. In this CO2 have to get from that only for that calcium carbonate for the decomposition reaction. Otherwise we have to go for that calcium carbonate along with hydrochloric acids. So in presence of hydrochloric acid we can get calcium chloride and water molecules and along with the versatile carbon dioxides. Okay. So this is the preparation of the carbon dioxides. Then go for that what is the properties of that carbon dioxide. The properties of carbon dioxide, I am going to implement the 3100 Kelvin of the temperature. This is one of the reversible reactions. We can come again to the previous state. So how to get that? After the 3100 Kelvin, we can get that carbon monoxide and the half of the molecules of the oxygen. And then go for that another one, the high temperature and more than the 3100 Kelvin, we can get that carbon and oxygen. It's there for the properties. And then go for that reducing behavior. How to behave that carbon dioxide for that reducing agent. I already explained about the reducing agent acting of the carbon already. We have to done in the metallurgy lesson I think. I think you have to remember that. So in this carbon dioxide also have to playing that reducing behaviors. In carbon dioxide react with what is that Mg? So magnesium, and then go for the magnesium oxide with the carbon, and then go for that water gas equilibrium. Why I am going to tell about the water gas? In these equations is one of the reversible reactions, also have to call as a water gas equations. In this water gas equations have to get the water molecules in a gaseous state. So that only we have to call at what is this? Water gas equilibrium. So carbon dioxide react with hydrogen. We can get that carbon monoxide with the water molecules in the gaseous state. Okay, this is that reducing behavior along with the water gas producing of that carbon dioxide. Now go for that acidic behaviors. Okay, in acidic behavior, if the carbon dioxide react with any of the acids, what will happen? Have to go for that the equations. Carbon dioxide react with water molecules, we can get the carbonic acids. In this carbonic acids also have that the reversible reactions, but it's not the completely consumed. Have to go through on that the further reactions. It have to be separately. We can get that the hydrogen ions as well as the carbonic ions. This is the steps for the acidic behavior of the carbon dioxides. Okay, and go for the structure of carbon dioxide. In this structure of carbon dioxide, you have to compare with carbon monoxide structures. In this carbon monoxide structures, have to join with the procedure to that same thing for carbon dioxides. Here, one atom of the carbon and 2 atom of the oxygen. You know very well about that. In this atoms have to surround out the octet rule. In this octet rule, have that 8 dots is there. So I am already explained about that 2 dots make a single bond. ஸோ 2 dots நீங்கள் வந்து ஜாயின் பண்ணுறப்ப சிங்கிள் பாண்ட் உங்களுக்கு ஃபார்ம் ஆகும் நான் சொல்லியிருக்கேன். ஸோ அதே மாதிரி உங்களுக்கு அந்த சர்க்குலேஷன்ஸ் போகும். ஃபார் த ஸ்ட்ரக்சர்ஸ் ஆக்சிஜன் 1 2 3 4 5 6, ஸோ 8 சொல்லியிருக்கேன். ஸோ இந்த 8ல் இங்கே வந்து ஒரு பாண்டடாக உங்களுக்கு ஃப்ரேம் ஆகிருக்கு. அகைன் வி கோ ஃபார் தட் கார்பன் and the oxygen already 1 2 3 4 5 6, so remaining 2, so I am going to mention the 2 dots. You have to rectify about that carbon atoms around the 8 dots. So in carbon 1 2 3 4 5 6 7 8, so you have to verify whether the atoms, not atom, that the electrons you have to surround at the octet rule. ஒவ்வொரு எலமெண்ட்ஸ்க்கும் சுற்றி உங்களுக்கு 8 எலக்ட்ரான்ஸ் இருக்கும். இது ஆக்டெட் ரூல்ஸ் படி. ஸோ இந்த எலக்ட்ரான்ஸ் ரூல்ஸ் வந்து என்ன அப்படின்னா 2 எலக்ட்ரான்ஸ் இருந்தால் உங்களுக்கு ஒரு சிங்கிள் பாண்ட் ஃபார்ம் பண்ண முடியும். ஸோ இப்போ நீங்கள் அதே மாதிரி நீங்கள் செக் பண்ணியாச்சு. ஒவ்வொரு ஆட்டம்ஸும் சுற்றி உங்களுக்கு 8 எலக்ட்ரான்ஸ் இருக்குது. ஓகே, அண்ட் தென் கோ ஃபார் த ஃபர்தர் another 2 electrons have to form the another one single bond. So obviously we can get the single bond convert into double bond. So again we have to go for that the cyclic procedure. In this bonding have to go for the 2. So உங்களுக்கு வந்து என்ன ஆகும் அப்படின்னா ரொட்டேஷன்ஸ் டைப்பில் இங்கே இருக்கக்கூடிய 2 பாண்டட் ரெண்டு எலக்ட்ரான்ஸ் வந்து ஒரு சிங்கிள் பாண்டை ஃப்ரேம் பண்ணும். திருப்பி இங்கே இருக்கக்கூடிய 2 எலக்ட்ரான்ஸ் சிங்கிள் பாண்ட் வந்து உங்களுக்கு இந்த இடத்துல பிளேஸ் ஆகும். ஸோ இப்போ நான் உங்களுக்கு காமிச்சிருக்கேன் பாருங்கள். இந்த இடத்துல வரக்கூடிய இந்த ட்ரிபிள் பாண்ட் உங்களுக்கு மறுபடியும் இந்த இடத்துல வந்துச்சு. ஏன்னா அப்படின்னா உங்களுக்கு சைக்ளிக் மெத்தடில் எலக்ட்ரான்ஸ் வந்து உங்களுக்கு அப்படியே என்ன ஆகும்னா சைக்ளிக் மெத்தடில் ட்ராவல் ஆகிட்டே இருக்கும் பாண்டிங்ஸ். திஸ் இஸ் த ஸ்ட்ரக்சர் ஆஃப் கார்பன் டை ஆக்சைட். ஓகே, அண்ட் go for that another topics, that is silicon tetrachloride. In silicon tetrachloride, how to manufacturing to, I am using that explanation through this formula. Silicon dioxide along with 2 molecules of carbon and 2 molecules of chlorine, we can get what is that silicon tetrachloride, that is SiCl4. 4 means tetra, so silicon tetrachloride along with carbon monoxides. Okay, and then in commercial silicon tetrachloride we have to manufacturing through the only laboratory method, but we have to go for the commercial method. So carbon dioxide or any other manufacturing உங்களுக்கு 2 டைப்ஸ் இருக்கும். ஏன் அப்படின்னா கமர்ஷியல் டைப்ஸ்னால் உங்களுக்கு வந்து the amount of the percentage வந்து நம்மளுக்கு கம்மியாக இருந்தால் we cannot survive in the world. ஸோ நம்ம கமர்ஷியலாக கூட மேனுஃபேக்சரிங் பண்ண வேண்டியது இருக்கும். ஸோ அந்த மெத்தடை நம்ம பார்க்கலாம். சிலிகான் react with hydrochloric acids. Silicon react with hydrochloric acid, we can get again the silicon tetrachloride and 2H2, that is the hydrogen atoms. Okay, and then go for the silicon tetrachloride, the properties. In these properties have to connect with the water molecules of 4 and then have to get 4 molecules of hydrochloric acids and then silica, that is SiO4 4 times, that is called also silica. Okay, this is the properties of silicon tetrachloride. And we go for that another equations for ammonia lysis. Ammonia lysis means we have to implement the ammonia substance to the silicon tetrachloride. We can get what is that chlorosilazanes. Chlorosilazanes, the chemical formula is Cl3SiNH This is also called what is that chlorosilazanes. This is one of that most important equations is there, and the most important concept of the category of silicons. Already we have to learn about the silicon tetrachloride, but we have to learn about that silicons. In this silicons, quite interesting concept for that last also. The polysilicons, siloxanes, also called polysiloxanes. ஏன்னா இந்த oxanes மெத்தடில் உங்களுக்கு அந்த ஸ்ட்ரக்சர் ஃப்ரேம் ஆகிருக்கும், அதனால we can call also the polysiloxanes. Okay, and also we have to call upon that organosilicon polymers. இந்த ஸ்ட்ரக்சரை பேஸ் பண்ணி தான் இந்த நேம்ஸ்லாம் நம்மளுக்கு வந்திருக்கு. In that silicons, the empirical formula. In this empirical formula, have to write R2CO, alkyl carbon monoxide, that is alkyl carbonyl groups. Empirical formula I have to mention that R2CO. Okay, and we have to get it the structure. So many varieties is there for linear and cross linked. So many varieties. I am going to explain you the further classes also. And before that we have to go for the preparation of silicons. In these silicons, I have to RCl with Si. In this alkyl chloride react with the silicons in presence of copper with 570 Kelvin and go for, we can get the R2SiCl2, that is dialkyl silicon dichloride. That is, we have to get the preparations, and again we go for that another chain polymers. In chain polymers have to explain about that. What is that? Cl, SiCl, you have to mention that R, the alkyl metals. In that alkyl metals have to convert into that alkyl metals, but the chlorine convert into hydroxyl ions. Okay, this is that. In this hydroxide ions have to move on that cyclic method. It will frame the different type of shapes of silicons. In this silicons have the different type of shape is there. I am going to show you in further classes. The structure of silicons, we have to continue this. I will send the notes for you in using that books. நீங்கள் அதில் ரெஃபர் பண்ணி பாருங்கள். How to be in the linked crosswise and linear wise, எப்படி லிங்காக ஸ்ட்ரக்சர் ஃப்ரேம் ஆயிருக்கு அப்படின்னு சொல்லிட்டு நீங்கள் பார்க்குறப்ப it will be very clear, I think. And then go for that types of silicons. Okay, this is the types of silicons. There are so many varieties is there. I am going to read out the some kind of silicons varieties, that is linear silicons, cyclic silicons, cross-linked silicons. In this, linear silicons have to be subtitles, that is silicon rubbers and silicon resins. And go for the cyclic silicons and cross-linked silicons have to be the variety of that called silicons. And go for that properties and uses. What is that properties of the silicons? Have to go for the properties. It's a cross-linked nature of alkyl group and determine the nature of the polymers. Nature of the polymers determine பண்ணுறதுக்காகவும் அது நம்மளுக்கு யூஸ் பண்ணுறாங்க. அது மட்டும் இல்லாமல் the viscosity of silicon oil remains the constant and does not change the temperature and they don't thicken during winter. அப்படின்னா இன் வின்டர் சீசனில் நீங்கள் ஆயில்ஸ்லாம் பார்த்துருப்பீங்க. சம் கோகனட் ஆயில் கூட வின்டர் இந்த ஊட்டி இந்த மாதிரி மவுண்டன் பிளேஸில் இருக்கக்கூடியது உங்களுக்கு அப்படியே உங்களுக்கு சாலிடாக இருக்கும். பட் சிலிகான்ஸ் எடுத்துட்டிங்க அப்படின்னா உங்களுக்கு எந்த டெம்பரேச்சர்லேயும் உங்களுக்கு அதோடய ஸ்டேட் வந்து மாறாமல் இருக்கும். அது கொலாய்டல் ஸ்டேட்லேயே அப்படியே அது ஸ்டேபிளாக இருக்கும். அதுதான் அவங்க சொல்கிறாங்க. தட் இஸ் அ வெரி இம்பார்ட்டன்ட் ப்ராப்பர்ட்டிஸ் ஆஃப் சிலிகான்ஸ். அண்ட் த யூசஸ் ஆஃப் சிலிகான்ஸ் ஆல்சோ ஐ எம் கோயிங் டு டெல் இன் த எண்ட் ஆஃப் த கிளாஸ். And then the types of silicons is there. For I am using the diagrams through this book, it will be very clear to understand that. Okay, in this structure of orthosilicates have to bonded the silicon and around surrounding the 4 atoms of the oxygen, so that we can call tetrahedral ionides. Okay, this is the first type, that is called also orthosilicates. And go for that, the sorosilicates have to combine the 2 atoms of that tetrahedral. இப்போ நீங்கள் செக் பண்ணி பாருங்கள் அப்படின்னா tetrahedral orthosilicates உங்களுக்கு 2 times உங்களுக்கு bonded ஆகிருக்கும். So this is also called sorosilicates. And go for that ring silicates. In this ring silicates, in silicons have to surrounding the 3 oxygen atoms, we have to make the shape of the triangle. And then go for the ionosilicates. Ionosilicates, you have to notice that the linking number உங்களுக்கு வந்து linkingல oxalate alternative உங்களுக்கு கிடைக்கும். In the silicons have to bonded with the oxygen, 3 oxygens. Okay, this is one of the types. And another types we have to go for that, the structure of double chain silicates. You have to notice this is the single chain have to bonded with the another chain, so it will call double chain silicates. And then go for the sheets or phyllosilicates. நீங்கள் பார்க்குறப்ப இது வந்து ஒரு ஷீட் மாதிரி இருக்கும். It look like a stars also. So the structure of sheets phyllosilicates have to bonded with the silicons, the 3 oxygens. So this is the types of the silicates. Also is there. For that you have to using the examples for feldspar and zeolites also is there. Okay, I am going to explain the small thing for zeolites. We go for that. The zeolites. Zeolites means the 3-dimensional crystalline solids. In the zeolites பார்த்தீங்க அப்படின்னா it will, the structure is look like a honeycomb. Honeycomb already we have to done about the previous chapter, that is graphene. You have to notice that the page number 43, graphene structure, it's look like a honeycomb நீங்கள் புக்ஸ் நான் சென்ட் பண்ணுவேன், நீங்கள் அதில் செக் பண்ணி பாருங்கள். இந்த honeycomb it's bonded with the oxygen with the silicons, that is also called the zeolites. In this zeolites is the last concept of this lesson, p block elements. In this p block elements have not completed, have to continue this third lesson also, p block elements part 2. So part 2 இருக்கு உங்களுக்கு third lessons. So we have to go for that another information and go through that informations also. And before that I am going to tell about some uses of the silicons. Okay, the uses of silicons, it manufacturing of lubricants, and as well as we have to go for that manufacturing of grease also using that silicons. And more than it will usage of that the waterproof sheet, that is the household useful for that waterproof sheets also. And the another uses is the most important, the electrical motor equipments also. And then go for that another uses, that is the so many variety of materials of the using the daily life. Okay, this is the uses of silicons. You have to understand, I hope you. Okay dear students, we have to complete that p block elements part 1 successfully. So you have to read out through and from the beginning of that last. Okay, and we have to learn about the 13th group and as well as the 14th group. Okay, boron and carbon family. So you have to read well, and I will send it in the notes as well as after the video the homework also. So you should complete that the homeworks and have to send it for that particular time, evening 5 p.m. Okay, thank you.